Motion is a familiar concept. In daily life, anything that moves is in motion. But how can you tell if an object is in motion? Motion can be defined as the movement of an object brought about by force. Force can simply be either a push or a pull. We can tell that we are moving only in relation to some other objects that are not. We refer to these objects as reference point. The motion of objects can be described by words. Words and phrases such as going fast, stop, slowing down, speeding up, and turning provide a sufficient vocabulary for describing the motion of objects. As we have been talking about, physics is a mathematical science. The concepts and principles have mathematical basis. Distance, displacement, speed, velocity, and acceleration are mathematical quantities. Mathematical quantities related to motion can be divided into two categories: scalar and vector quantities. Scalar quantities that are fully described by a magnitude or the numerical value alone, such as time and speed. While vector are quantities that are fully described by both magnitude and direction. Direction can either be north, east, west, south, up or down, and front and back, such as velocity and acceleration. We are presented with a table that includes vector and scalar quantities. Vector quantities include displacement, force, velocity, acceleration, torque, and momentum, while for scalar quantities, it includes distance, mass, speed, time, and work. As an entry card for our next meeting, you are going to answer these questions. Identify each quantity as being either a vector or a scalar quantity, and then you need to explain why. For our first topic, we are going to discuss distance and displacement. As an object moves, its location undergoes change. There are two quantities that are used to describe the changing location. One quantity refers to distance, which is the amount of ground covered by an object. The second quantity is displacement. Displacement is only concerned with the initial and final position of an object. Displacement is the overall change in position of the object from start to finish. There will be an instance wherein your distance will be equal to your displacement. The only thing that will differ from the two is the direction. Let us take this as an example. We have a line with corresponding measurements. The interval measures 5 meters. We also have a picture of a dog and a tree. Which of the two objects do you think will be the reference point? Correct, it is the tree. Now for our distance, let us say that the dog will run towards the tree. What distance will it cover? It is 15 meters. Now, what distance will the dog cover if it runs 10 meters past the tree from its original position? So 10 meters past the tree or beyond the tree would measure 25 meters. That would be the distance covered by the dog. Now, do you get what do we mean by distance? Distance is the amount of ground covered from point A to point B. What if we add another variable to our demonstration? Let's say a house. Now measure how far is the tree from the house. It is 10 meters. How far is the dog from the house? It is 25 meters. So let us have this as the situation. What if the dog ran towards the house? What distance will it cover? The dog will cover the distance of 25 meters. As another situation, after coming to the house, the dog ran towards the tree. What distance did it cover? So from the house to the tree, the dog will cover a distance of 10 meters. Try adding the distance of 10 meters with the distance that the dog covered from running from its original position towards the house. What will be the total? It is 35 meters. This is now what we call the total distance. Total distance is the sum of all distances covered by an object. Now for the idea of displacement. As we have defined earlier, displacement is how far the object is from its starting position to its final position. Let us still use the pictures as the variables. Question 1. What distance will the dog cover if it runs towards the tree? It is 15 meters. Now think. How far is the dog from its original to its final position? Is it still 15 meters? Yes. Then, this is what we have been talking, that distance can be equivalent to your displacement. What would be the difference between the two? You are only going to add direction for the displacement. So displacement would be equivalent to 15 meters to the left, towards the direction that the dog covered. For another situation, if the dog starts from 0 meter, runs towards the tree, and continues towards the house, then turns around and returns to its starting position, what is its displacement? The displacement would be equivalent to 0 meter because the dog returned to its starting position. Now to finalize, distance refers to the amount of ground covered by an object, while displacement is concerned with the initial and final position of the object. Total distance is the sum of all distances covered by an object. Displacement again is how far the object is from its starting position to its final position. There will be an instance wherein your distance will be equivalent to your displacement, and if the object returned to its original position, the displacement is 0.